So my project is on credit card fraud detection using AutoML tool called RapidMiner. Now, I know you have discussed with us about MIME and H2O, but I went ahead with this RapidMiner because there was a competition in Kaggle as well running parallelly, which specifically asked us to use this tool, RapidMiner. Okay, so this is my agenda. I'll quickly give you a data overview and how to perform feature engineering, feature selection, training the model, etc. using the tool. Now, doing it in the tool is pretty quick. So I will do a quick sample on this tool and show you how it's done. Now, since it's quite new, I'm explaining this on the tool. If you have any doubt at any point, feel free to stop me and ask. So first we go and grab the data. Train data. This is my train data, right? So I need to look how my data looks like. So whichever aspect that you want to look at, just connect the output of that particular operator to this output port key. You can simply double click as well and then run it. Then you can look at the table. So if you look at the left side bottom, you can see this table has 150,000 examples. Examples are nothing but the rows. And you have 0 special attributes and 32 regular attributes. Attributes are nothing but your features. Special meaning they are like objects or strings which needs to be converted. We have 0 such special attributes and 32 regular ones. Regular ones are like integers, floats, etc., which can be directly fed into the model. Now, right away, we can actually look at the distribution of your data by clicking this turbo prep. And you can see the distribution about the data, right? So the ID is uniform. We are not going to use this for our model anyway. It's just a unique key number for each credit card transaction. Then you have time, which is not normal. Then you have some features. We don't know the names of these features, but we have this data and we know the distribution. Some of these features are normally distributed, like feature 4, we have feature 9, feature 11, 13, etc. And we have the name of one column, which is called transaction amount. And you can see this is also not a normal distribution. Most of the transactions are below, maybe something like $500, something like that. Then is fraud, this is our label, the final dependent variable. Now, if you look at the distribution, this also we have most of the values are like the zeros, not a fraud transaction. That's what happens, right? The fraud transactions would be quite less. You can quickly visualize that. Just go to the results. Sorry, the screen is coming in between. Yeah, we go to the results and click on visualizations. And here, if we select that particular feature is fraud, you can plot this and you can see is fraud 0, meaning not a fraud transaction. So almost 149,731 of these transactions are not fraud, and only like 269 of these transactions are fraud. So this is my data set. So first thing that we need to do is we need to decide which is my label, dependent variable, and which are my features. For that, you need to go to blending attributes, and you need to go to names and roles. You need to set the role, right? So you need to drag that operator to this example here. But when you do that, the link to the output is missing. So if you still want to keep seeing your table, you use an operator called multiply, which basically means, you can create multiple links using this. So just attach it to multiply. One link you can give it to the output so you can keep seeing your table. The other one will go to your model. Now here I can actually set which of my feature is my target or my final label. You can select the label target role here and just apply it. But also one thing to do is here you can actually check which of the data types of my features, right? If I scroll down and see data type of my is fraud is integer. So we are going to do a classification algorithm algorithm on this. Either it should be true or false, 0 or 1. So before you set the role, you need to actually change the data type. That we'll do quickly by going to blending, examples, attributes, and changing the data type from numeric to binomial. So from integer, you want to set it to, let it be there. From integer, you want to set it to either true or false. So here you need to select which of these features you want to do that. Only one, not all. Is fraud, this is your label. This one you'll change it from integer to binomial, right? Once this set role is done, you can generate new attributes if you want. If you remember, some of our features are like, look at this transaction feature. It's not normally distributed. Or maybe let's look at maximum and minimum values by going to results and statistics. All the features are like ranging in between maybe minus 40 to plus 40. But the time, if you look at it, the maximum value is 73,899. And similarly for transaction amount also, it's very high. So in such cases, you want to actually generate new attributes using that so that you can actually standardize them. Right? You can simply type here whatever attribute you want to do. Since I know, I can just quickly type generate attributes. Or you can simply go to blending. All this data change will be done through blending. Go to attributes and generation. Generate attributes. Now, what am I going to do here is take out your examples, which are your rows, and generate two new attributes, right? Instead of time, maybe I will apply log of time. Log regular attributes time, since the time is ranging from 0 to a very high number, I will apply log over it. I give it a name log of time, and another entry log of transaction. Log of transaction amount. Then we have generated two new attributes. Apply. Now you can see how your values look like by just connecting it to the output port key and then running the model. It's better if we look at the statistics. If you look at the new attributes that are generated, log of time and transaction amount, see the least value is minus infinity for time. For transaction amount, it's fine. So we cannot feed this into the model, right? Minus infinity, because there is a value 0. So log of 0 will be minus infinity. So maybe instead of log, let's apply something else on this. Maybe we'll discretize using the bins, right? So you can create bins using the operator called discretize. Discretize by binning. And connect these attributes here. Discretize, not all, just your time. Maybe you want to have 6 bins or maybe 8. And then remove that time from here. Remove entry. Also for log of transaction amount, just to be on the safe side, my live data can have 0 transaction amount for some reason, we don't know. So you can simply just type 1 plus transaction amount so that you don't have that minus infinity error. Can do this with time as well. Apply. So you have all this now. Now maybe now the thing to do is you need to convert our labels from nominal back to numerical to be able to fit into the model. Let's do that. For this, we again go to types in my blending, attributes, types, nominal to numerical. Take this and change your time basically right now, if you see at this point of discretize, just go, just hover over this examples part and press F3. You can look at the data types of your features. So for time, it's actually nominal. That one will change it back to numerical before feeding into the model. So select time, single time, and you can just use dummy coding or some unique integers. Anything works. So I think we are done with all the data cleaning or feature generation part. Now what we can do is select the attributes. We don't need all these attributes to be fed into our model. So you go to again blending selection part, select attributes, grab this one here, include attributes, right? We want to decide which attributes to include, not all, but only a subset of it. If you remember, we have created two new attributes, right? So we'll remove the old attributes of that. Log of time, we can use it. Time we can remove, transaction amount also we can remove. Right? Selection is done. Now we are going to split the data into 70-30%, or whichever percent you want to have for train and test set. And then you can choose the model and run it. So I'll quickly go and do that split. So like I said, you can simply type it here, split data, right? Example sampling, split data. So you can simply double click here and type the numbers, 0.7, 0.3. This is my ratio. So for reference, you can also note it down here. Split data 70:30. So here I can actually just select one model and run my data through, right? Maybe say logistic regression. So you can simply connect it to the logistic regression. So this 70% of the data will go to the model, and the rest you need to verify with how it's performing. For that purpose, you need to use this operator called apply model. What it does is after training your model, apply model, after training your model using logistic regression, it applies it on the rest 30% set. It will connect it to unlabeled data, and you will connect the logistic regression model here. And it will give you the output in terms of labels. But you want to check different performances, right? Different types of performances, either ROC, AUC score, or accuracy, etc. So I'll just select simple performance and see whatever it gives. So connect it to the labels here, connect it to your outputs, and that's it. You can run the model now. So here you can see, this is my classification matrix. So here you can see the trues are quite less. So this is a basic quick model I have run. In my actual model, I have used gradient boosting, random forest, and all that. We can see that results in the PowerPoint presentation. Just to quickly demonstrate, I have used this model. So if at all you want to use other models, you can do that as well fairly quickly. So what I wanted to show here is, if at all you wanted to, kind of run using AutoML tool, it takes less than 5 minutes. Once you are pretty aware of all these operators and all, it takes less than 5 minutes to build a model. Okay, you can add as many models as you want. So now let's go back to our presentation. It's nothing but the elaboration of the tool, the kind of data I have used, number of examples, etc. Then this is my actual model. If you see logistic regression, apart from that, I have other models as well. You can't see it here on the screen, but I'll show it in the upcoming slides. Then standardization, I have simply divided by the maximum amount here for the transaction amount, and selection of features. We don't want that ID and transaction amount. And the add a boost, gradient boosting, and all other tools I have used, techniques I have used, so that my score on true is high, because this is what the main objective is. If you look at the accuracy, it's 96.45. It's less than our logistic regression, but the business objective may be different, right? They might be interested in more truths. As in, I want to flag more fraud transactions. It's okay if I'm also flagging normal transactions as fraud transactions. It's just the transaction will get declined, but at least I'm able to save the fraud transactions from happening. So yeah, just to improve that prediction and recall performance, I have used all these other models like naive Bayes, gradient boosting, and random forest. It's all pretty quick, like I have explained. You just have to type in the model or select whichever model that shows up in this here in operator. See trees, right? You have many other models. When you go to predictive, you have Bayesian, trees, rules, neural nets, logistic regression, etc. You can simply grab those. So you can also look at the feature importance, right? You can also look at the visualizations by selecting this particular tab with visualization. And if you want to remove maybe some of these features, you can quickly do that, right? You can go back to your select attributes component, just click on select attributes, and you can remove which of the features you don't want. But you can see the problem, right? It's quite easy to do it here because my number of features is quite less. If I have something like more than 1,000 features, then it gets quite tricky to use AutoML model. So yeah, that's how you can do feature selection. I have kept it how my model has true truths and falses. And for just for comparison, I have also ran this model through this thing called Turbo Turbo Prep. Right here, you can quickly create the model just by clicking on model. You can actually select what is your final variable. Let me just move this. Yeah, dependent variable. Click on next. Turn it into classification because it's a classification model. Click next. Select all your inputs. Basically, you can select or deselect. Let me just select all, just for demonstration purpose. As for models, you can just by toggling this off or on or off, you can quickly select different types of models and click run. It will give you the results as shown here in this PowerPoint. Now it's going to take a lot of time. That's why I'm not running this, but this is how it will look eventually. Okay. And before I end this presentation, I wanted to show you this link for those of you who are interested. I provided this link in this PowerPoint itself, or maybe I can paste it in this chat if you're interested. So you can download this and you will get a 1 year free trial. It also gives you a lot of courses on how to use this tool. There are many courses like this is the one course that I tried to do for the purpose of this project. This tool is on machine learning. So it gives you a quick walkthrough on different types of machine learning models, right? Getting started with the tools, the GUI interface, different models, machine learning models, till your deployment. Apart from that, it also has a lot of courses on various applications for AI, ML, and data science, even for data engineering. Once you're done, it also gives you a certification. It conducts 1 hour exam, and if you have that certification, you can directly link it to your LinkedIn. Okay, so yeah, that's about it. I try to make it as quick as I can. Thank you guys for your patience and giving me this opportunity.
Thank you. This is a great job. Yeah, I really like it. I'm glad you actually chose a different tool, RapidMiner, because we covered 9 in our class. They're both very popular no-code machine learning and workflow design tool. I don't have any questions regarding the machine learning models or your approach. The only suggestion I have is that I noticed that under like the scores and predictions, you have, ML models 1_2_3. I think you had a multiple models, right? So the way you name these models are using like, a sequence number. My suggestion here is that when you work in a production environment, and then when you do like experimentation, oftentimes you're going to data scientists will do many experimentations, and they will slice and dice the data and create subsets, do sampling, right, and just try different things out. So they will have different subsets of the data, and then they will also train many different types of models. naming these models and data sets can always be confusing. So one of my suggestion is, let me share my screen. Yeah, I would suggest you look into something called MLflow. It's an open source project for model experimentation. So MLflow is not part of RapidMiner. I just did a quick Google search and it looks like it has an integration with MLflow. So what you can do is you can run Docker or basically set up MLflow on a server. It could be local as well. And then you can use the plugin to connect to the MLflow server. But essentially what happens is that you will be able to have access to the MLflow service that keeps track of all the models because every time you run model training or run some sort of pipeline, it will log that and not just log the model itself, but the trained models, visualization, all the metrics, right? You can decide what metrics you would like to log for a specific experimentation. So that actually can be very helpful, and a lot of companies use this in production. Okay, so that would be my only recommendation. Overall, it's very well done.
Yeah, thanks, Jawahar.